We're gonna take away the superstars.
Stars! No!
Don't worry, it's not the real people. They're still allowed, I think. I'm going to be presenting how.
We can't see the projector.
Yeah, but I'll move it for when we get. I'm just going to introduce. This is for melody catalogs and scale catalogs. What it is fundamentally is just value series catalogs. So categorization of series of values, which you can express easily in numbers. 1, 2, whatever. And the reason I'm doing them is melodies, and I think melodies is probably the best word for them. Not necessarily, because it doesn't have to be pitch related. But melody in the sense that it's a non-smooth curve. Now, the way I make these series is by, just like you do polyrhythms, by fusing several constancies. So, for example, if you, which we call ratios, for example, if you have, for example, a 4 against 3. So the speed of 4 against the speed of 3. So this is how they are all made. So if you have 4 in 1, this is going to be a bit inverted. For example, you would have, so if this is 1, 2, 3, 4, 5, 6, 7, 8. So the distance between here and here is 2. So you have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1. Against 3, which would be 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. You see, here they meet again. So what you get is, so what you have is two constant speeds fused together become what we call a polygon. So this would be a 3, because the distance between here and here is 3. Then between here and here is 1. There's 2, 2, 1, 3. Is it understood? So by fusing constant, they don't have to be constant. It's just that when they are constant, they're much easier to handle calculation-wise. When they're moving, it becomes extremely much more complicated. So I'm just sticking with constants for the sake of it. So when you fuse several constancies, you get these shapes. Let's say these are rhythms, polyrhythms. Poly because they just made it of several. So what I'm going to be focusing on is the ratios. The ratio is expressed in this case in the form of pitch, with melodies. So, for example, classically you would do this in rhythm. So this becomes longer, short, middle, middle, short, long. For example, this would be the classical way of doing it, just like church bells work this way as well. You have 2 bells that go at different speeds. By mistake, so you usually get these really long ratios. It takes a really long time to repeat. Besides having also mechanical problems, which means that they're not constant, which means that they can go to almost infinity with small variations.
Is it possible to quickly demonstrate the bells with sound?
Change.
Yeah. Can you pick 3 pitches? 3 pitches, for example, ABC, where this is A, and this is C, and this is B. And just like this.
Just write it down.
3 is A,
Okay.
1 is,
1
is C, this is, and 2 is B. we're not,
Kidan, king, kage,
Yes.
ka.
1, 2, 3, 1, 1, 2, 1, 2, 1, 1, 2, 3, bam.
Can you do
Bam,
polyrhythm with 2 fingers? Like I said,
The thing is that we're not really going to be working with polyrhythms.
no, it was just to clarify this idea of polyrhythm, because maybe for some people it's not so clear.
To clarify the idea of polyrhythm.
Yeah.
In a very simple way, like how the bell sound we could play.
No, but you already no. The bell sound is just because the thing is that the bell sound is very easy because of the techniques in which because you have the pendulum techniques for this. When you don't have pendulum techniques, it actually becomes very complicated
Yeah.
unless you do it simple.
Yeah, if you think it's not relevant, no problem.
No, because I'm not going to get into rhythms
No.
at all. So I'm doing it this in the simplest shape, which is the one of pitch.
But you are talking about rhythm
Mm,
with 4 against 3.
yes, in a way. No, only as long as I apply to duration. I'm talking about values. And I'm talking about values that repeat themselves. You have the value of 4, which is repeating itself. And the value of 3, which is repeating itself. Now, if you apply to duration, you get rhythm. So, durational form. A melody would be the equivalent. So, if duration can be translated to pitch, rhythm is the melody of.
But then you have to explain why the 3 is A and the 1 is a C.
Yeah, no, so this is a further translation, exactly. Very good point. If you do this in duration, then you have 1, 2, 3, 1, 1, 2, 1, 2. That meaning that 2 is twice as long as 1. Which would mean that if you do this literally into pitch, then if this is A, then this is A an octave down.
Down.
Yes,
Okay.
slower.
So,
Not harmonic series.
no,
Forget
no.
harmonic
Yeah,
series.
okay.
Because this is twice as long. So I'm skipping this. I'm just taking the values and then applying them to another surface. And this is where I do the scales. The scales become the synthetic surface on which everything else travels.
That's poetic.
It's poetic, it doesn't need explaining. So forget that, yes, just read these sequences of values, please. Now, there is characteristics to this which I use to differentiate them from any other ratio. And that's 3 characteristics. On the one hand, so if this is x against y, where x is always bigger than y, in this case, the difference between x and y, or rather, in this case, the duration before it repeats, because if you continue, you just get the same thing in repetition. So this is one full cycle. So what you can calculate on the one hand is how many events, how many values do you have before it repeats. In this case, you have 1, 2, 3, 4, 5, 6, which is the same, which you calculate just by doing 4 plus 3 minus 1. So it's always x plus y minus 1. Even if you have 13 against 12, it's going to be 13 plus 12 minus 1, and, which is 24. And that's how many events, how many values it takes before it repeats itself. So on the one hand, you have x plus y minus 1, which gives you what you could call the density. Density in the sense of how many events do you have per cycle. On the other hand, you have, which determines how long it becomes, for example. If everything is the same duration, then, yeah, it makes how many, anyways. It's how many events per cycle. Then the other aspect you have, for example, in this 4 against 3, is the value of y. If y is 3, you will, which is the smallest, it will always, in the series, it will always be the biggest value. Here, for example, since it's 4 against 3, and since y is 3, you only have 1, 2, and 3, which then repeat themselves in different patterns. If you have 5 against 4, then then you would have 4 different values in different patterns. But in this case, you only have 3 because of 3. So you have the value of y becomes equal to the amount of different values you have in a melody, which means how many pitches are you using for the curvature in the melody that you're doing.
So Ivan, just to clarify, the -1 is because this.
The
In
minus
this
1,
case, the seventh value would be the
minus
first
1
one.
is because they meet
The
at
seventh.
one point.
In this case, the seventh value would be the first one of the next cycle. In this case,
No,
the seventh.
no.
value.
Here it becomes 3 again.
Yeah, no. Now I'm because now x plus y minus 1 it would be 6. So I imagine there are 6 events per cycle with.
Yes.
So
1,
that's-
2, 3, 4, 5, 6.
Yes, and the seventh would be the first one of the next cycle.
Yes.
Oh yeah.
If you go on, if you repeated this,
Yeah, well, I just.
if you repeated this, the reason it's -1 is because there's a point where they both meet.
Right.
If you
Yeah,
don't
yeah,
have,
okay, now I get it.
this
It's like
is
the
one.
octavation part.
Yes.
Yeah.
If they don't meet, then it would not need -1. But in this case, since they meet,
So the,
and in all the other cases, they do meet as well. If they don't meet, then you're calculating with the wrong ratio. You need a bigger ratio for this stuff.
is there a ratio that does it never meet again?
No,
No.
unless you do infinity against
Yeah.
infinity plus 1.
Okay.
Probably never. Infinity against infinity plus 1, probably never. Or meets in infinity.
Yeah.
-1. So it just meets in infinity.
Yeah.
-1.
Yeah.
Kind of like to do that, but
Yeah, we will. But I don't think we have time for that.
probably not.
And then the third aspect, which is the one I'm going to concentrate most on today, because it's, or at least for the first part of it, because it's the most subtle one. Like this is very easy to hear. You simply hear longer melodies that go on for longer time or shorter time. This also, you hear the difference if it's a melody that only goes between 2 pitches, or if it's a melody that goes between 3, or if it goes between 10 or 20. Then the other one is the distance between x and y, which in this case is 1. This expresses the number of phases. And with phases, here they start together, then this one comes a bit earlier, then it comes even a bit earlier, then even a bit earlier, and then finally they meet. If you have, I'll make an example of a simple 2-phase one. If we do, for example, a 5 against 3, well, the difference between x and y is 2 rather than 1. We get so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5, 5, 1, 2, 3, 1, 3, 1, 3, 2, 3, 3, 1, 2, 3. Here they meet again. Here you get 3, 2, 1, 3, again, 1, 2, 3. What you have here is, as we saw in the other one, which I think is an example put here. Here they'll start, then it comes a bit earlier, it comes even earlier, but then it comes even earlier before the next one happens again. And then soon you meet again. So, I don't know really how to explain this didactically. This is what I mean with phases. Like they'll catch up on each other. The phasing aspect is not really that, it's important, but it's not really that important because what I focus on is that it gives you another kind of curvatures. When the distance is 1, you will always have long, short, long, short, long, short, long, short, long, same, short, long, short, long, short, long, short, long. So you always get this kind of zigzag motion. We eventually get down and then get up again. And here, when you have a distance of 2, there's always going to be a point where it continues. Like here, it's 3, 2, 1. So it goes from long, middle, short. It doesn't jump to its extremes all the time, but it does have lines. To 1. Then 3 directly. 1 directly. So here it goes back to long, short. And then it goes middle and low. So you get by the difference between x and y, you get into the curvature differences. If the distance between x and y stays the same, so if you have 4 against 3, 5 against 4, 6 against 5, 7 against 6, etc. You get, what you get is basically almost the same thing, just at longer and longer and longer. But you always get this ba beep beep ba ba beep 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 ba 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 ba. And what's with this? You get the ba ba beep ba ba. And then if you get longer, then you get ba beep ba ba beep ba beep ba ba beep ba. So you get these curvatures inside, and the bigger the distance is, the more curvatures you get inside of the rhythm that are not just jumping to each other's extremes.
You can maybe also explain it a bit more simple. You will get repetitions.
Yeah, you also get repetition of the values, exactly.
Yeah, and the larger
And
number.
especially the largest one. So here you have 3 3s, well you have 2 of all the
What I
two
mean is that
twos.
one of the layers is repeating. So the bigger the distance between x and I, the more repetitions of one layer you get.
Yes.
And that's
I mean, we can take it to the extreme, for example, where you have, well, and not hyper extreme, but still more. Where you have, for example, 10 against 2, 11 against 2. The reason I take 11 and not 10 is because 10 and 2 are both divisible by 2, which means that you actually end up having 5 against 1. So it's these two. So 11 against 2. You understand? I don't think we have enough blackboard space to actually. But I can just write you out.
Just the beginning, and
what
you
it would
already
be.
see.
Okay, just the beginning. So you have 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. 1, 2, 1, 2, 1, 2, 1, 2. Actually, you might for that. I'll go here. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4.
No, it's one further.
1, 2, 3,
2,
4, 5.
4,
1,
6,
2, 3,
8.
4, 5, 6, 7, 8, 9, 10.
Yeah, okay.
11. Yeah.
Then you already see that you have 4 of the 2, or 5 of the 2.
No, I'm doing something wrong. Yeah. So here they meet again, right? So what you have is 2, 2, 2, 2, 2, 1, 1, 2, 2, 2, 2. You end up having a lot of repetitions and then one break and a lot of repetitions. Now in 11, of course. Okay. So the cycle of 11 happens twice, and the cycle of 2 happens 11 times. 1, 2, 3, 6, 7, 8, 9, 10, 11. And then it starts over. Okay. Here the distance between them is what gives us also these. It's a very different curvature from the 4 against 2, for example. Again, you will hear the difference very clearly. It's much more. child. So pa 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 1 2. Pa 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 pee pee pa 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 pee pee pa pa pa. Very different. And this is what you get, especially by going into this. So I would. This is usually the hardest thing to hear, except when you take it to the extreme. So this is what I'm going to be focusing on in general levels. But now, you understand how these are made? Just so I don't have to. Okay. Now I get into reversal. So, I've then made a catalog. So I've told you I use the duration of the cycle in terms of events, so x plus y. The number of different values that are active, which is the value of y, the lowest one, like 4 against 3, you only have 3 values, and then the curvature. Then I've made the processes, and I will show you, first. These values can be applied, because I'm getting into melodies specifically, but I did a few scales just for the melodies, which are nice to show. Stop hearing my voice for a while. Where you have, when you do it into scales, I mean it's versatile. When you do it in scales, the values we saw, like the 3, 2, 1, 2, 2, 1, 3, 2, 1, 3, 1, 1, 2, 3, for example, this in the 5 against 3. You just apply this in melody where 1 equals a minor second. Did you play a minor second? 2 equals a major second. 3 equals a minor third. 4 major third. Perfect fourth, etc., etc. So and then for these you just pile them. So what used to be 3. What used to be 3, 2, 1, 3, 1, 2, 3, and 5 against 3 becomes then that you start. You go from a certain pitch, you go up a minor third, then you go up another major second, then you go up another minor second, then you go up another minor third, minor second, major second, minor third. So you just kind of pile them on each other, and this becomes the sequence for how the scales are made.
Can you play that?
The first scale or?
Could you play
3, 2, 1,
play this?
so minor third, major third, etc.
A pitch and then a minor third up. Major second. Minor second. Minor third. Minor second. Major second. So that's what you see here is 3 scales, one made out of 7 against 6, with a difference between 7 and 6 is 1. I wrote out the sequence in numbers, which is, so you see here, since 6 y, so 7 is x, 6 is y. This is worked out. So, and here, since the difference is 1, you see that the series is 1, 5, 1, 6, 1, 5, 2, 4. You have this zigzagging motion between them. You go down, up, down, up, down, up, up, etc. Could we play the first scale? interval, big interval, small interval, big interval, small. And these go contracting. We'll play it again. Big, small. So you get these pictures. And of course this is not dealing with octaves and so on, which also give in other qualities. Since we're doing it in scales, 7 is, for example, what the intervallic value of 7. Since it's 7 against 6, one thing you know for sure, 7 is going to be happening all the time. The difference of 7. 7 is the equivalent of a perfect fifth. So this scale that goes on, this scale will always contain the cycle of fifths, for example. Like you have these, when you apply them into pitches, then you have all this, it gets in conflict with all these other qualities which also happen here, which you don't necessarily see in the ratio of which. Then the 9 against 4. Well, actually, the scales is not going to be the focus of today. So just play the 3 different scales, one after the other. So just get over with it. So here you could hear many more repeated intervals after each other. As discussed, I don't know what it is. So these are the melodies. Or this is this melodic process. Each line is its own melody. So you get the first, which is 4 against 3, 7 against 5, and against 7. And the thing here is, the way I organized this was that I have a scale where, as I told you, the x and y, either the x minus, either the distance between them, the total, the number of the cycle, and how many pitches it contains. So I organized them where I have processes where you'll go from for example, you'll go from a few values, so from a small y to a big y. So from where the smallest ratio, for example, from 3 grows to 7, grows to 9, grows to 11, grows to 13, grows to 15. As 4, also as the 4 against 3 is in a distance of 1, it grows to a distance of 2, and 7 against 5 grows to a distance of 3, and 10 against 3 to 7, to a distance of 4, and 13 against 9, to a distance of 5, and 5 and 16 against 11, a distance of, etc. Distance of 6 and of 7. So both the distance, so if you imagine this is, if the bottom line is y and the top line is x, on the one hand, you have the distance between x and y is small in the beginning and big in the end. The value of y is small in the beginning and higher at the end. And the total amount of x plus y is smaller here than here, as you see. 4 plus 3 minus 1 is a much smaller number than 22 plus 15 minus 1. So here you have where all these three aspects are going in the same direction. In the next one you have where all, in the next melody, number 2, you have this, where you have where x is growing and y is diminishing. Though x is growing faster. The result of this is that you go from a lower total sum to a higher total sum, a bigger distance between x and y, but a decrease in y. So you get all three aspects are moving, but only two of them are going in the same direction, and one of them is going in the opposite direction. So 2 of them are growing, the other one is shrinking, or the other one. So on. I would like to emphasize the x minus y, the distance between them, the qualities that come in the distance between them. I want to try to, because with these two. Number 4 and number 6. The reason I picked these two is because number 4, you can see the y is static. As you see, it's 6 against 5, 7 against 5, 8 against 5, 9 against 5, 11, 5, 12, 5, 13, 5. So it's melodies that all consist of 5 pitches. Whilst the total number of 6 plus 5 is smaller than 13 plus 5, as well as 6 plus 5 is 1. But 6 minus, the distance is also increasing. So I've never tried to organize it outside of my head for other people, so I'm not quite sure. Like if you miss something,
But
please.
it helps if
Yeah.
you play every now and then.
Yes, okay.
Yeah.
Let's play the 6, let's play the number 4. With repeats. Repeat each one about 3 times.
First one of number 4.
Yeah. First, then second, then third, fourth.
Okay.
Here you get more and more curves as the distance grows. But the pitches are the same. You get more and more fives as the distance gets bigger.
It looks as if the third one has most information in the middle. Second two, because when
Because it's
to the
before
end it becomes less because of all the repetition.
Yeah.
And in the beginning it's always zigzag.
Yeah.
So you could say that the maximum
The
of
third
melodic
one is,
information is a bit in the beginning.
Yeah.
Maybe the second, third,
No,
maybe
as
fourth.
soon as, especially as soon as you cross the octave, or actually right before the octave, when x equals y times 2 minus 1. is when, yeah. Can we play them again? Maybe a bit faster.
This one.
Oh, the fourth one.
Yeah. Looks like
The fourth one is the one that's more similar to the first one. Especially when you're looking at it.
they're also mirrored, huh? Always.
No, the all symmetry. I'm not quite as interested in the symmetry of them, but yes, they are all symmetric.
And that's the obvious consequence of the
Yeah.
approach.
Yeah.
But you could do something about it.
Yeah.
Yeah, or just not.
But this is a catalog.
This is a catalog. Or if you do, no, if you add ornamentations, you can do
Or you could stop where the symmetry starts. Don't consider the
Yeah. No, I think I need to figure something out. I would like to compare this to the sixth one.
Can you make it a bit bigger, that we can actually read the numbers?
Maybe.
Yeah, you can.
Yeah. Yeah.
Now the sixth one, so we just played this one where the y is constant. So the x is always growing, but the y is constant. In the sixth one, and we also noticed with this one, the first one is in total shorter than the last one. So it's also growing in this one. On the sixth one, it's not the case. It's not growing. They are all exactly the same length. And that is because, well, because both y is shrinking at the same rate as x is growing. Now what you have here is that the length stays the same, the number of pitches is decreasing as the distance between the two of them is increasing. So you get very zigzaggy 8, 1, 7, 2, 6, 3, 5, 4, 4, and you end up with a 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 1, 1, 2, 2, 2, 2, 2, 2, 2, 2. Okay. What's the second one? We want to get this happening twice and the rest in zigzag. That is the last that it's continuous. This is the 20 next one.
This sounds more than just a catalog to me.
What's just a catalog?
This sounds more than just a catalog.
What is just a catalog?
For me, I
What's
no, I find
Shorter
it
set.
just like to.
that they're too long. You mean?
No. No,
Or that catalogs doesn't have virtues.
No. No, I mean, when the order, it's very important and it gives a strong meaning to what's happening. And I think that the relationship between the different ratios is really important, and also here in this order is very
Yes.
meaningful. So that's what I mean. It sounds like music to me.
Yeah. No, but the catalogs are complex things.
Indeed.
More complex. I mean, they can bring a lot of qualities you don't get out of them. I don't think I would have automatically made the connection between 9 against 8 to 15 against 2, or like pom pom over to pa 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 pa.
Somehow also very organic, the development of these.
Yeah, I mean also symmetries has this tendency some music.
No, but not within the same thing, but in this sequence.
In this, yes. No, they're always stepwise developments from each other. The changes between them are very
And
slight.
it's very logical and when you hear this.
Yeah. And then there is one more I want to show you, and I think that will be the end of the time we have. Because I don't get the time to explain how I organize them from 1 to 6 necessarily very well. So because it's a macro catalog as well. It's the year of the catalogs. I've been dedicating my year to catalogizing stuff. Finding principles and then yeah. Anyways, now I would like to show an example where the x minus where the distance does not change between them at all, which is this case, where both x is growing and y is growing at the same rate all the time. So that it starts with 7 against 2, and then the difference between them stays the same throughout the whole, which is this number 5. To be precise?
Yeah.
So you see, you start with 7 against 2, 8 against 3, 9 against 4. So the difference between them is always constant. So basically, what it should become, unless I'm really getting it all wrong and doing something I don't, is that the curvature is the same in each melody, and the only thing that develops is kind of its length. So the number of phasings and the number of curvatures is the same, just that it's expanding. And with more and more pitches. Okay. Also repeat 3 times each.
I don't understand what you mean by that the curvature is the same.
No, to me this is curvature, like when you have the very small, but the thing is it's two things going on, and there's one thing that I really haven't figured out quite yet, and that is, which is not y nor x plus y nor x minus y, and that is the ratios, also relationships to their octaves. Because here you have 7, like 7 minus 2 is 5, so the distance between them is always 5. But there is a very big difference between 7 against 2, or for example, when you go over to
Yeah, the last
12
one.
against 7.
Yeah, or the last one.
Yeah, because 7, as long as x, like there's also a relationship to when x is, to how many times bigger x is than y. So for example, when you get to 13 against 6, or even 11 against 6, it's very similar to 14.
No, but
like you have
It could become 979 against 970.
what I mean is
Then it becomes very complicated.
what I mean is 7 against 2 has very little, which is the distance of 5, has also very little to do with 35 against, no, not 35 against 30, but 36 against 31,
Yeah.
which is also a difference of 5. But there they're getting so close that
So it's also x divided by y. Like if you have 7 against 2, it's 3.5.
exactly,
And that's much more simple number
Exactly.
than
exactly.
the higher you get. So that's the fourth element that should play a role probably.
This is the fourth element. They should play a role or straight off substitute the x minus y. Because the x minus y is rather deceiving. Because this is the point where the x minus y only kind of works for the very simple ones. And for It shows differences, but it doesn't, its difference doesn't repeat itself. Because the x plus y difference does repeat itself, and the y does as well. To my ears, at least. But this is, yeah, that's what I still need to solve eventually. When I get more excited about it.
It's a really cool way to zoom in and out. Or this idea of getting closer, getting farther. For me, the 7-2,
Yeah.
the 14,
No,
the
for
same
sure.
thing, it's just a
Yes.
different
Yes.
distance. And
Yeah.
I like this a lot.
Yeah. We can, and maybe I can show you an example, because this is the zooming of this, where maybe we could do an inverted zoom, a zoom in, but where the number of pitches also increases as the zoom out. So you both zoom in
Because
as
it's
the number of pitches.
I think this idea of zooming in and out is interpreted so many times in music in very different ways. But sometimes it's very hard to actually hear it. But in this case, you really hear it. And
Yeah.
I remember discussing this with Paul Berg. And yeah, he can be very severe about these metaphors in music. But I think he would appreciate it. I mean, this would make sense.
I think we can zoom in and out at the same time, depending on if we can handle the aspect. Like, no, it doesn't do it.
That's like it.
But here, no. It could do that here very much, where you both go from a very small distance between them to a very big one, at the same time as you get more pitches, which is a zoom out. You increase the resolution. Oh no, zoom in.
Zooming.
You increase the resolution. At the same time that the distance gets much bigger. So you get a lot more of these kind of 11 against 2 repeats. Da, 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 ti, ti, da, ti, da, 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 ti, ti. But I haven't done any melody because to extremely big size. I think it goes from 3 against 2 to like 21 against 16 or something like this, which is not such a big difference.
Ivan, perhaps it would be helpful if you're actually using one of the, I've seen the examples, but if you take one of these items and actually write out a scale on the board,
Yeah, I meant,
like in the moment, like show how you got those note values, because it's hard for
how I got
the notes, yeah,
of the scale or the melody?
of the scale. Not sure actually.
Because you got a melody on the one hand, and then you got if it's a C major, if it's a C minor.
Yeah.
No, so the scales is kind of what I briefly explained at the beginning, but which is constructed in exactly the same way.
But they can start on any note, it's just not the intervals.
Yeah, no, so here it just goes, like you have the scale, and then you just say, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So when you have the low one, which is 1, you play that one. If you get a 6 in the series, then you go to the 6th one. So you do higher, lower, stuff all that. But you'd like me to write how I got the...
Like take number
Like-
1 for example, and
Yeah.
give it a value and write a scale from that. You do that, right?
He wants to know the connection between the scale and the actual
Yeah, I
melody.
can't really connect it.
Yeah,
Yeah.
that's very
I'm
good.
very
Show the scale first, then you can explain. Because the first one is based on what scale? Or this is the second one? Doesn't matter, you can take just take one.
The first one is based on the first scale, on the A.
So what are the numbers of the first one?
On the first scale?
No, of the first melody.
Oh, the first melody.
So the first number. Just a few notes, you don't have to do the
Yeah,
whole
yeah,
thing.
yeah. But I don't know how to put 2 PDFs in the same.
No, but you can write it.
I'd rather
you
you
can write it
actually,
on
I'd
the
rather
blackboard.
write it and then like write like
How does it start?
numbers,
X and I, what are they in the first one?
Yeah.
so take an arbitrary value or
So the first one is where X grows with 2. So we're both X and Y are increasing.
We do one with
But-
4 against 3.
One more, sorry?
We do one with 4 against 3.
Yeah, do that.
Since that kind of connects back to
Yeah.
the first example.
You can start with 4 against 3.
Okay.
Now it's the first one which goes where both are growing.
Yeah. And what
So-
note do you want to start on?
You don't have to do the growing, just 4 against 3 gives you 3, 1, 2, 2, 1, 3. Right?
Yeah.
Then you explain what notes they are. That's all.
Ah, okay, okay.
Like,
So you
start
get
on-
3, 3, 1, 1.
So if we have the scale started from the middle G then,
Okay.
this is the scale. From the G, D, D sharp,
So G or G sharp?
G sharp.
G sharp, D, D sharp, and then we call this 1, 2, and 3. Now if we have the 4 against 3, this is the scale setup. If we have the 4 against 3, that gives us the series as we saw before, the 3, 2, 1.
No, 3, 1, 2, 2.
Oh, I was thinking 5 against 3, sorry. 3, 1, 2, 2, 1, 3. So this is our melody before we got the pitches. Then, to put this over to here means that we get 3. So, D sharp, 1. G sharp, 2, D, then 2 again, 1, G sharp, and the 3, D sharp.
Okay, I think I get it now.
So this becomes then 3,
Yeah. This was the missing part.
2.
Yeah.
Ah, I see.
That's what I told you in the beginning.
Yeah.
When
Okay.
you did the A, B, C.
So this is how they are all made. So you pick up a scale, you name them on the scale. Because I mean, you could also do this just on chromatic scales, but it becomes a lot more.
And 1, 2, and 3 can be any 3 notes.
1, 2, 3 can be any 3 notes. As long as 1 is lower than 3, or 3 is, I mean, you can choose that to count it like this as well.
So if we're 5 against 4, you then have
But
5
then-
different notes.
But as long as they are in a series. I mean, they can also be not, but then you lose the control series.
If it were 5 against 4, you'd have then 4 different notes.
Yes,
It's always the bottom note, bottom number, that amount of notes.
exactly.
So you can't really have 975 this. There are 975 notes.
Not on a
Yeah.
piano.
Not on instruments.
Not
Not on
non-electronic instruments.
Yes, violin.
Yes, that's true. Yeah, then
I don't know if you have mine or not.
also voice.
We
No,
had
but what you can also do, I mean, like you can take it to a combination of pitch and instrument. Like if you have, let's say if each instrument had, to not exaggerate, like 48 notes. Let's say 88 of the piano. No, or 48 notes, and then you have 10 different instruments. And then the instrument, it both becomes scale and instrumentation. If you have a full orchestra, you can easily do with such a big number.
It could also be done with quarter tones.
And quarter tones and such as well.
But it would be too big to understand the overall thing, right?
And then apply it to non-Western music.
Yeah. Yeah. No, but the thing is that these you can just apply anywhere. It's how to deal with the qualities of certain curvatures. And the reason I'm saying melodies and not curvatures is because curves are smooth. And here you're jumping from one thing to the next without the smoothness between. So melodies becomes just conceptually a better word for it. Or really. I don't think we have any more time. So any more questions? What do you want to hear another melody? Before talking about it. No. It's 8?
Yeah.
Ah, we have time for another melody. Okay. Yeah, these are the 2-layer ones. Like if you do 3 layers, you get more complex stuff, of course.
But yeah. We gotta get the
Okay, which one would you like to hear?
Play the one you like more.
Okay.
I like the really low ones. So
Yes. That's the
That's a
low.
free choice, right?
We have
Because you
free.
could
They're
put
not,
it anywhere.
that's just my free choice. If we were
That's just very passionate.
Okay, we dig where everything is moving in the same direction. The most unison melody, which is also the first one. Play it, Sam.
Yes. This is open platform from anyone who would like to present something. We have still one more to go in June.
6th of June.
Yeah.
6th of June. We might have some free time.